All right, here's a video of all the solutions to both days, day 9 and day 10 of review problems. We had some factoring problems, so you can see I've put the boxes on all of them except the first two. This is how number 4 factors right here. A couple of different ways to do it, so don't be too confused here. This is one way using factor by grouping. This is also factor by grouping, but moving the terms around first. So, but you get the same answer either way. And there's this one, also factor by grouping, but this factor right here, y squared minus 9, factors out to y minus 3, y plus 3. Sketching the graphs, so there's the first one, third degree. Next one is also third degree with a double zero there at -3. And the third one is an upside down, that is negative oriented, fourth degree polynomial with 2 double zeros. So there's that. Here's the next problem. We were just dividing. Okay, find the quotient and remainder. Okay, I did it 2 different ways. Actually, this is, no, sorry, never mind. So this is using long division. I got my quotient up here and the remainder is down there. Or synthetic division, clearly takes a lot less time. There's my quotient and there's my remainder. Since x minus 1/2 is a factor of this polynomial, to show that it is a factor, all I have to do is perform the synthetic division using 1/2 as the divisor, and I get a 0 remainder of 0. So since the remainder is 0, that means x minus 1/2 is a factor. Okay, emphasizing the fact that if you know the zeros, then you know the factors, and vice versa. So here, in number 11, we're told 2 numbers that are zeros of this big polynomial here, a fourth degree polynomial. 1/3, I work that through, I get a 0. Now I'm going to use -2, the other number given, on this quotient here. So I put -2 in for this, and I get a 0. Now I've got this quotient, 3, -6, -9, which is 3x squared minus 6x minus 9. I'm going to find the zeros of that. And so for me, the easy way would be to factor out the 3, and then that gives me this, and then I can factor that quadratic quite easily. So there's my 2 zeros for that factor, and so the total, here's all the zeros. Okay, there we go, number 12. Given that, oops, sorry, wrong page. Given that x plus 2 is a factor, find the other factors. Okay, there we go. So if x plus 2 is a factor, I should be able to divide it by -2 and get a 0 remainder, which I do. That gives me a 1 here, a 1 there. That's x squared plus 1. That doesn't factor. I could use a quadratic formula, but I think I'm going to go a little bit easier route and say x squared plus 1 equals 0. I subtract 1. I get x squared equals -1. I solve and I get plus or minus I. So my other 2 factors are x minus I and x minus -I, or x plus I. There's the 3 factors. Number 13, find all the zeros of this big hairy fifth degree polynomial. We've got a constant of 9, a lead coefficient of 4. So my P over Q values that I will try in synthetic division are these numbers here. 139 over 124. So that's all of these possible numbers here. Turns out that 3 works twice. I get a 0 for using 3. I try 3 again, I get another 0. We tried 1/2 and we got a 0. Then we got this quadratic quotient. So we started with 5th degree, then 4th degree, then 3rd degree, and now finally 2nd degree, or quadratic. And it doesn't factor, so we used the quadratic formula and solved it and simplified all the way down to these 2 numbers right here. So these are the remaining 2 zeros. Okay, so the zeros are 3, 1/2, -2 plus root 6 over 2, and -2 minus root 6 over 2. Let's move on. So today's problems were simply finding all the asymptotes and intercepts for a bunch of functions. I kind of did them in a different order here. Here is exponential function, and these are the horizontal asymptotes, vertical asymptote, there aren't any, no x-intercepts, y-intercept of 1. Log function, no horizontal asymptote, but the vertical asymptote is x equals 0. X-intercept 1 and no y-intercept. So look and contrast those 2 things. Here's a graph of one, here's a graph of the other. They're inverses. They switch places. Horizontal becomes vertical, x-intercept becomes y-intercept, and vice versa. Okay? Here's another exponential function, but it's been altered a little bit, raised up 1, so our horizontal asymptote is y equals 1. We've got, if you let x equal 0 to find the y-intercept, you get 3. Okay? If you take this log function, it's been shifted to the right 2 units. So so its vertical asymptote is x equals 2. No horizontal asymptote. And if you let y equal 0, remember that's e to the 0 equals x minus 2. You can work that out and get the x-intercept is 3. And there is no y-intercept. Let's move on. Those rational functions. Oops, sorry, wrong page. Did it again. I gotta go this way. Sorry. And you should, if you haven't already, check your notes on rational functions about finding asymptotes and intercepts. So I'm not going to speak too much through this, too much talking. I'm just going to kind of slowly pan through those 3 problems. Okay, you can come back to this if you need to. Okay, but be sure to check your notes on finding the asymptotes and intercepts for rational functions. Okay, so the binomial expansion problems. Here's a plus b to the 5th. It works out to this top line. I'm using that as a model to expand 2 minus root x to the 5th. Simply, and I know this is hard to read. I'll zoom a little. I'm replacing the a with the 2 and the b with a negative root x. Okay? 2 to the 3rd, negative root x squared, 2 to the 2nd, negative root x to the 3rd, etc., etc. I'm choosing, then I'm 2 to the 4th is 16 times 5 is 80. And I'm writing with fractional exponents to make use of the pattern a little bit better there. Okay? So, if I have x plus y to the 10th, those binomial coefficients, refamiliarize yourself with that. For these, it's 5, 0, 5, 1, 5, 2. In other words, the first term is 5, 0. Second term is 5, 1. The third term is 5, 2. So if I want the 7th term of this, that's going to be 10, 6. Okay? So 10, 6, the exponent of the second thing in the binomial has the same as that. Okay? That's always true. Unless that had a different one to begin with. If that was squared, then this would be different ultimately. But you can use the same pattern. Then these 2 exponents here always add up to that number. So there's always this pattern going on with these things. You can figure out 10, 6. All right, that's your coefficient using the formula or using your calculator, and you'll get the same number. So the 7th term is 210 x to the 4th, y to the 6th. We're going to try that one more time. The 6th term of this expansion would have 8, 5. Okay, that equals 56. It's going to have negative 2y to the 5th power and x to the 3rd. 5 plus 3 equals 8. So this exponent and that one are the same. So I work this out. That's negative 32 to the 5th times y to the 5th power. 56 times negative 32 is this number here. So that's how that works out. That's your 6th term of that expansion. Let's do the last group, evaluating some logs. Wrong page. Dang it, I did it a 3rd time. I'm such a doofus. Okay, last time here, last page. Evaluating these logs, you can check those out. Okay, all of those. 2.5 for the very last one. Various ways to get to that. Number D, or part D and E. I'm showing kind of a couple of different ways you can get to those answers. That's 2.5, and this is just 10. Okay? The domain and range of log and exponential functions is really important to kind of emphasize this here. These 2 functions are inverses of each other. Log, exponential, same base. They're inverses. The range of one is the domain of the other, and vice versa. Okay? The domain and range swap places for inverses. And that's clearly true for exponentials as well as anything else. Here's another exponential, but it's been lowered or shifted down 4 units. Therefore, the range has been shifted down. But the domain is always all real numbers. Okay? So I got a different range because it's been shifted down vertically 4 units. This is a log function that's been shifted to the left 3 units. So my domain is now shifted over. And remember, the argument of a log function always has to be greater than 0. So if it's not clear to you what you do, just take that, set it greater than 0, and solve. Pretty simple little inequality to solve. There's your domain. The range is all real numbers. Okay? Okay, good. Bye. See ya. Have a good weekend.